Okay, so we talked about the rain shadow here, and we talked about how as warm, moist air has to be pushed up and over mountains because they're very tall, okay, it loses all of its moisture because the water vapor cools enough that it condenses and falls on the windward side of the mountains, okay? That's, for us, British Columbia, okay, this is the windward side. And then it comes down the leeward side, okay, of the mountains, where we are, okay, and it comes down, it's cool, it's dry as it's coming over the top, it warms as it descends from a combination of friction and you know, having the sunshine on it, whatever, okay, all of that comes down the mountains, warms as it descends, and then it's dry and warm, and when it comes over the surface here, it can actually pull moisture, okay, out of the ground and out of trees and things like that as it passes over. All right, and then that's how a Chinook is born, okay. Leeward is the side of the mountains that is the dry side, essentially. Okay, this is the windward side here. Okay, because the wind is blowing onto it, and this is the leeward because it's blowing off of it. Yeah. I would remember just in case I use that terminology in a question. Like, it's just something that's, I mean, I understand that it's windward, leeward to me, but I'll try not to. But yeah. All right. Patterns of prevailing winds. Where do our winds typically come from here? From the west, from the southwest most of the time, but usually west. We're in the part of the earth that experiences the prevailing westerly winds, which means typically we're getting air masses coming from the same place. Okay, they're coming from the mountains. Right? And so typically we get, you know, certain weather patterns because of that. Now, are there occasions where that doesn't happen and where we get wind coming from another direction? Yeah, okay. When we're about to get some major change in the weather, the wind does not come out of the west. Okay, the wind is usually, if we're going to get something bad, okay, to happen weather-wise, it comes from the north, okay, and it starts coming down. Well, let's use a different color here. Okay, usually starts coming down out of the Arctic, okay, like this. So if we get something out of the northeast, it is usually bringing cold Arctic air down to us. The problem with that is that not only are we not getting air masses from where we usually get them, southwest, but there's usually an interaction of several areas of high and low pressure. Okay? Pressure changes are things that cause changes in the weather because usually high pressure air masses don't have very much moisture in them and they tend to be cooler. Okay? Low pressure air masses tend to be heavy, wet, and usually kind of warm. All right? Up here, okay, in like Nunavut and the Northwest Territories and whatever, okay, that's typically a high pressure area. I just can't seem to pick a color that really works here. There we go. Okay, that's typically a high pressure area. Most of the time it's clear skies and cold in the winter, clear skies and kind of warmish in the summertime. All right, but over here, okay, like by Prince Rupert, Fort St. John, okay, that kind of area. Okay, typically this is what actually a lot of meteorologists call the mother low. Okay, because low pressure areas spawn from that area and they kind of swirl off of it and they come straight down off the Rockies. Okay, so let's see here. Circulation around a low is this way, I think, if I remember my meteorology class. It's clockwise. Okay, around a high, it's counterclockwise. I might be backwards on that. Don't quote me. It's not something you'll be tested on. Okay, so what happens is you get a high pressure area coming off of here, okay, and starting to travel down, okay, through Alberta. You get a low pressure area coming off of here. So you've got cold, dry air interacting with warm, moist air. That's, yeah, like fire and gasoline. Okay, it is always going to cause some major weather system to form. All right, and so that's when we get the big blizzards coming down because this cool air makes all the moisture in here, and there's lots of it, condense and form rain or snow. Okay, and that snow goes all the way down the province. Look, right down Highway 2. Right, that's why Highway 2 is always such a death trap in bad weather. Right, because it is right beside the mountain. It kind of runs parallel to the mountains. Okay, and as a result, the mountains kind of funnel all of that snow right down the center of Alberta. Okay, everyone follow me there? Yes? Okay, so certainly there's these locations of high and low pressure can cause cyclic weather patterns. And we do. We tend to get, cycles of nice kind of weather like we've been getting here, and then we get cycles of other kinds of weather, okay, where, yeah, it snows for 3-4 days straight, okay, and then it's kind of cold after that as a high pressure area kind of sets in, okay. Low pressure areas tend to be kind of short-lived. They come through, they deposit their moisture, and they take off, okay, whereas high pressure areas, they kind of stall, and they'll sit over an area, which is why in the summertime sometimes you get like really hot dry weather for a week and a half, okay, and it's just clear and dry the whole time. That's when a high pressure area stalls, okay. In the wintertime, when a high pressure area stalls over top of us, you get those cruel days, okay, where you look out the window and it looks beautiful outside. It's bright, it's sunny, and it's -40. Okay, right? That's what happens when we get one of those Arctic high pressure areas sitting over top. Okay. All right, so high and low pressure areas can kind of make that stuff happen. And if you ever watch, like the Weather Channel or whatever, and you see the guy, he's always, drawing all these circles and he's got lines all over the map. Basically what he's showing is here's low pressure areas, here's high pressure areas, and anywhere where there's going to be active weather is right where they meet. Okay, and for us in Alberta, they always seem to meet right about here, okay, and they go right down the middle of the province, okay, which is usually why when we get something really bad, it's province-wide. Okay. Now, are there occasions where it's not province-wide? Yep, once in a while, we just get it. Okay, once in a while it just happens down here. Well, once in a while you can get low pressure areas coming in from like off the coast of Oregon and places like that, and they'll move up, okay, and come from our prevailing southwesterly direction. If that happens and there's a high pressure area from the north coming down, then we tend to just get it in here, okay, and then it usually gets pushed off into Saskatchewan and into Manitoba. So once in a while we get those as well. Okay, now on Highway 2, where's the worst spot? Anybody know? If there's going to be a closure on Highway 2, it's always near this place. You guys haven't been driving long enough to know the answer to that one. Okay. Yeah, it's south of Red Deer, actually. It's right around Olds. Yeah, it's right about there. Okay, right around Olds. Always the worst spot. Okay, why? Well, there seems to be just a bit of a gap that stuff can get through the mountains. Okay, there seems to just be a gap and stuff just seems to get through right in that spot. Right, and so warm, moist air manages to get through the gap in the mountains as opposed to having to go over. Okay, and if it interacts with anything coming down this way, then you seem to always get the worst kind of weather kind of right in there. All right, so those are the factors. Remember, we got to remember the difference between the two things we talked about in that lesson. There are the components of climate. And the components of climate are temperature, precipitation, light, and wind. Okay, essentially the things that make up weather. Okay. The factors are the things that affect the temperature of an area, precipitation of an area, wind of an area, okay, light of an area. Okay. What was the #1 factor? Latitude. Okay, how far from the equator you are is the #1 factor, okay, affecting climate because it affects how much solar radiation you receive. All right, climatograms. Okay, climatograms are just essentially a quick visual reference type of graph that we use to show the two biggest components of climate. Okay, it can't show wind. Right? But it does show temperature and precipitation, which is what we're kind of most interested in terms of weather. So a climatogram shows these things by having essentially two different kinds of graphs on the same graph. Right? We have a bar graph that shows our precipitation, and then we have a line graph that shows our temperature. Everyone with me so far? Right? So in a place like a tropical rainforest in Manokwari, New Guinea, okay, what are we seeing here as a pattern? The bars are precipitation. The line is temperature. Right. Its temperature almost never changes. It looks like it's 33 degrees every day. Okay, now this is broken up into months. Okay, so there's each bar here is January, February, March, April. Okay, so by month, essentially, it never changes. So where do you suppose New Guinea is? Right near the equator. In fact, it almost sits on it. Okay, so because it's so close to the equator, the amount of solar energy it receives basically doesn't change. Right? So it has very even temperature. Now, what do we notice about the rainfall? Has a dip around October. The driest month, okay, they get 11 centimeters of rain. Okay, when we get 17 centimeters of rain, it floods here. Okay, that's what happens when we get 17 in a month. Okay, it floods. Right. So look at this. In their wettest month, they're getting over a foot of rain, not snow. A foot of rain. Now, is a foot of snow and a foot of rain the same amount of water? Not even close. 1 centimeter of rain is 10 centimeters of snow. Okay? Because when snow falls, it's got spaces, right? Okay, the flakes are very small and there's spaces between them. Snow is mostly air, which is why it's such a good insulator. Okay? So, yeah, this is a very wet place. That's why a tropical rainforest could form there. Now, they have their wet season and their dry season, okay, here. Right? But it's still pretty wet most of the year. Now, if we look at something that's more mid-latitude, so we're Nashville, Tennessee, all right, so kind of the middle of the United States from north to south, okay, we're seeing, what about, what's the rainfall look like here? It's pretty steady, pretty even, right? And that's sort of what you need to have a deciduous type forest. If you look at climatograms of like central Canada, it would be similar. You'd have a little bit of a dip through the winter months, but it's relatively even as well. And suddenly our temperature isn't a flat line anymore. Now it's a bell curve. Okay? As soon as you start to see a bell curve forming for temperature, you know you're nowhere near what? The equator. Okay? Now, the location of the bell curve will tell you about latitude. The location of this bell curve says that the warmest month is 28 degrees and the coolest month is 4. Everybody with me there? Now, Anchorage, Alaska, I think you would agree, a bit further north. Okay? Still the same shape, but look where the curve is. Warmest month, like 14 degrees. Okay? Coldest month, -10. Anchorage, Alaska is actually one of the warmest places in Alaska, okay, because it's near the ocean. Right? So it gets some temperature kind of regulation there. All right, now what do you notice about the rainfall? Right, there's a definite kind of rainy season, right, for Anchorage, Alaska, and that happens in the late summer, early fall. Okay, and then it's very dry. Now, it's not saying that they're not getting precipitation. They're getting snow, but remember that snow isn't, I mean, you can get lots of snow and it doesn't represent all that much moisture. Okay, so yeah, they're still getting precipitation here. It just doesn't look like as much. Okay, 2 centimeters of rain. That means 20 to 30 centimeters of snow. Okay, because this only ever measures the actual liquid water equivalent. Okay, everybody with me there? All right, now what I'm going to do is we're going to be doing an activity about analyzing climatograms, being able to look at them and go, okay, do these cities have anything in common? Okay, so what we want to look at is, here's climatograms of various cities, and then we want to look at where are these cities and what factors do they have in common. All right, so we're kind of reviewing here those factors that we just talked about: latitude, altitude, okay, presence of large bodies of water, mountain barriers, okay, things like that. Okay, so we're going to kind of group them together and see if we can find climate groups within Canada, which cities kind of naturally fit together. So, yeah, obviously ones that are close together geographically are probably going to go together, but you may find, okay, that cities that are not geographically close together may still fit in similar groups, okay, based on certain factors. Everybody with me there? All right, so that's kind of where we're headed here. All right, I want you to answer those questions here. I'm going to hand out the climatogram activity while you're doing that. Then we'll go over them. All right, so components of climate, okay, describe them as you think they are in central Alberta. Central Alberta is like Red Deer, Edmonton, that kind of area. Okay, so what would temperature be like? Right. It's a bit lower and it changes throughout the year. Okay, warm in summer, okay, cool in winter, right? Essentially is all you have to describe there. I wasn't really looking for a number because temperature varies. What about precipitation? Similar? Like, is it going to vary? Yeah, it does. It certainly varies. Okay, wettest months for basically anywhere in Alberta are going to be your kind of June, July are typically our wettest months. Okay, and then obviously in the wintertime, our precipitation falls as snow. We get a fair amount of it, but it doesn't represent a lot of moisture. Okay, what about wind for central Alberta? Wind for central Alberta is actually somewhat variable. It doesn't always come from the same place. They're starting to get into the spot where the westerly winds, where we are starting to taper off, and the easterly winds from the north are starting to come in. So their wind actually, they don't get a lot of it, and it comes from various directions most of the time. Okay, what about light? Does that also vary? Sure. Okay, it varies quite a bit. Okay, obviously in December they're getting much less light and much more indirect. Okay, the light they get is much more indirect, so they're not getting a lot of inputs of solar energy. Okay, things like that. All right, number 2, what factors most affect the climate in our area? Number 1 factor, latitude. We're pretty far from the equator. Okay, we're, well, over 50 degrees latitude. Okay, somewhere in there. We've got reasonable altitude here as well. Okay, we were saying the other day that we're almost 1,100 meters above sea level. Okay, so that makes a difference. And what would be the next thing? The mountains. Yeah, the presence of mountain barriers is certainly probably the next largest influence, and then I would say probably prevailing winds after that. Okay, centers of high and low pressure would come after that, I would say. The 4 big ones for us here would be latitude, altitude, presence of mountains, and patterns of prevailing winds, because we typically get southwesterly winds. Okay, climate of Saudi Arabia in terms of the components of climate and the factors that affect them. Okay, temperature, warm and not all that variable. Okay, fairly high all year round. What about temperature? Yeah, almost none, right? Sorry, did I say temperature? Sorry, precipitation was what I was thinking. Precipitation, dry. Yeah, it's a desert, right? There's practically no precipitation. For light, yeah, a bit of change, but probably not more than an hour and a half, okay, to 2 hours, you know, from the longest day to the shortest day, because they're fairly close to the equator. Okay, and what about wind? They're going to get easterly winds because they're close to the equator. Okay, they're going to get what's called the trade winds, okay, which blow near the equator. Okay, factors that affect their climate. Again, we've said several times they're close to the equator. Okay, the direction of their winds involves not bringing moisture in from the ocean, but rather pushing it out over the ocean. Okay, so that's why it's typically dry there. Okay, things like that. Yep, altitude would be what, close to sea level most likely for Saudi Arabia. Okay, that making sense to everybody? Yes.